Welcome to the fifth module, and this lesson will dive into computer vision, which is one of the most exciting fields in AI. Have you ever wondered how AI can analyze and understand the visual world? Well, the answer is computer vision. But what exactly is computer vision? Computer vision is a subfield of AI that enables machine to process and interpret the visual information from the world, just like humans do with their eyes. It's a technology that powers everything from self-driving cars to medical imaging. Let's understand how AI processes the visual data. Computer vision works by processing visual data, such images or videos, and breaking them down into pixel values. These values represent the intensity and the color of the light at different points in an image. From there, algorithms can identify the key features such as the edges or textures or patterns to understand what is in an image. What is the importance of computer vision in AI? Unlike traditional image processing, which require predefined rules, computer vision uses AI models, particularly deep learning models like convolutional neural networks, CNNs, to learn from large datasets and make predictions based on new images. With enough data and training, AI can recognize different objects and understand the context of the images. An important concept here, which is the image classification, which is the one of the foundational tasks in computer vision. This is a process where AI looks at the image and assign a label to it based on what it recognizes. For example, an AI systems might receive an image of a dog and classify it as a dog, or an image of a cat and classify it as a cat. But how does the AI knows what is it looking for? AI system uses the convolutional neural network CNNs to classify an image. A CNN break down an image into smaller regions to detect the patterns like edges and gradually builds up understanding of the object, going from simple features to more complex ones. After passing through these layers, the network produces a classification label that tells us what the image represents. A real world example of image classification, which is used in the social media by Facebook, particularly the automatic photo tagging feature. When you upload a photo, the system can automatically recognize faces and suggest tags for your friends. This is powered by AI that has learned to recognize faces and label them correctly. One more important concept in computer vision, which is object detection. While image classification is about identifying what is an image, object detection takes it a step further. Object detection involves locating and classifying multiple objects in an image and drawing a box around them. This task is more complex because the system must identify where objects are. In addition, what are they? But how object detection works? To achieve object detection, AI uses a combination of CNNs and region-based algorithms. These models scans an image to identify multiple objects and their locations by drawing bounding boxes around them. Object detections models are trained on vast datasets to recognize objects like people, vehicles, animals, and many more different objects. A real world example of object detection in autonomous vehicles. One of the most exciting applications of object detection in autonomous vehicles are self-driving car when uses cameras and sensors and AI-powered object detection system to detect pedestrians and other vehicles, as well as the road sign and obstacles, ensuring a safe navigation. For example, Tesla's autopilot system uses object detection to identify and avoid pedestrians while driving. One of the most interesting tasks in computer vision, which is facial recognition. This technology allows AI systems to identify and verify individuals based on their facial features. It works by analyzing unique patterns in a person's face, such as the distance between their eyes or the shape of their jawlines. But how facial recognition works? Facial recognition models typically uses deep learning algorithms to extract unique facial features called landmarks. These features are then compared to a database of known faces. If it match, if it match is found, the system can identify the person. For verification, the system checks if the person matches the one in a given ID photo, for example. What are the real-world example of facial recognition system, which is used, for example, in security field? Facial recognition is already being used in different industries, such as security systems, for instance. Facial recognition is often used to grant access to restricted areas, replacing the traditional methods like keys or cards. It also widely used in smartphones for unlocking the device. Next, let's talk about the image generation. One of the most exciting development in computer vision is image generation. With the help of models like Generative Adversarial Networks, GANs, AI can create new images from scratch or modify existing ones. GANs have two parts with it, which is the generator that creates images and the discriminator that evaluates them, ensuring that the generated images are as realistic as possible. But how GANs work for image generation? During the training, the generator learns to produce increasingly realistic images, while the discriminator helps to improve by pointing out the imperfections. Over time, this process leads to incredibly detailed and lifelike images being generated. What are the real world example of image generation? Have you heard of deep fake videos? Correct. So one of the most used applications of image generation is in deep fakes. Using GANs, it's possible to create incredibly realistic videos or images by swapping faces or creating an entirely fake people. While this technology has an entertainment application, it also raises an important ethical concerns, especially around misinformation. So, what are the other real world applications of computer vision? Now that we have understand the core concepts of computer vision, let's explore some of its real world application across different industries. The first example we have, which is the medical imaging and diagnostics. In medicine, computer vision is changing the diagnostics models which are used to analyze medical images like X-rays, MRIs, and CT scans to detect anomalies such as tumors, fractions, and diseases, often with greater accuracy than human doctors even. What are also the other examples that we have here? We will discuss about the retail industry, inventory management, and customer experience. In retail, computer vision is used for inventory management to enhance the customer experience, providing an AI-powered cameras that can track products on shelves, for example, ensuring that they are always stocked. It can also help businesses to understand customer behaviors through video analytics, improving the store layout and promotions. Next, we have the security and surveillance field and theft detection. Security is another area where computer vision plays a critical role. AI can analyze the footage from surveillance camera to identify the suspicious behavior, to detect security threats, or even matches faces to databases of a known criminal or people of interest. The next real-world application that we are going to discuss on an entertainment field, augmented reality and video games. Finally, in entertainment, computer vision is used in applications like augmented reality, AR filters, and interactive video games. For example, AR apps can detect person's face and overlay the animated effects in real time, creating a fun and engaging experience. The future of computer vision is very promising, especially with the development of the advanced AI models that more connected to the neural networks that will improve the accuracy and the capabilities of the AI models. Also, we expect to see broader applications that would expand the usage of computer vision into different industries and to solve real world problems and to serve business use cases. But still, there are ethical considerations while addressing the privacy concerns and potential misuse of the technology, as we mentioned earlier, as the deepfake technology. We also are expecting to see more integration with other AI fields by combining computer vision with natural language processing and robotics. Let's recap what we have learned so far in this lesson. We have covered the essential of computer vision from understanding how AI process visual data to advanced tasks like object detection and facial recognition and image generation. We also explored the exciting real-world application across different industries like medicine, retail, security, and entertainment.